Now let's consider the following function. G of t equals 2 over pi 1 plus 1 plus t squared. It's defined when t is positive. So can we use this function to model the waiting time for a bus? So this function can be graphed in the following manner. I'll do it for both the positive and negative values. Okay, when t is 0, we have 2 over pi. Okay, so I'm only concerned about this here because we are dealing with time. So it's defined for everything, but we are restricting it to just t bigger than 0. So if we model the waiting time as this one, this is, assume that I'm here, okay? So this is my time. So once the bus arrive here, so this is going to be the probability. Okay. So there are two particular points for this, two waiting time, two points for this probability. So when t is 1, okay, so the probability that I'll be waiting, if we assume that t is in hours, so the probability that I will be waiting for the bus no more than 1 hour. Okay, so that means I'm going to be here. I'm going to be between 0 and 1. Okay, if we compute this probability, so this is but this is a probability density function. We have to check that. That means we need to verify that g of t dt between 0 and plus infinity is equal to 1. Okay, let's do that first. So here, if we take 2 over pi outside, we have 0 plus infinity 1 over 1 plus t squared dt. And we know this as the arctangent function. So this is 2 over pi arctangent of t between 0 and plus infinity, or in another notation, it's 2 over pi, the limit of t as t goes to infinity of arctangent t between 0, let's put s between these two. So we have 2 over pi, the limit as t goes to 0 to infinity of arctangent of t minus the arctangent of 0 is 0. So here I know that's pi over 2. So I have 2 over pi times pi over 2, which is 1. So this is definitely a probability density function. And my question is, if we assume t is in hours, okay? So the probability that I will be waiting no more than 1 hour is, so I'll be in this interval. So that means I need to compute this one here. That means the integral between 0 and 1 of 2 over pi 1 over 1 plus t squared dt. And once I do that, I get 2 over pi arctangent of t between 0 and 1. So I have 2 over pi, the arctangent of 1 is pi over 4, minus arctangent of 0, which is 0. So here I have 1/2. So the probability that I'll be waiting for this bus less than 1 hour is 50%. Okay? The probability that I'll be waiting more than 50%, than 1 hour, is 50% as well. So the probability that I'll be waiting more than 1 hour, it's this one. It's the negation of this one. It's 1/2. Okay, because we know that these two, the sum of these two events is 1. Okay. So as time increase, the probability that I'll be waiting for something is going to be smaller. But here, so now our main important idea is here between 0 and 1 hour. So waiting for half the time is 50%. So waiting less than 1 hour is 50%. Is too high. Okay. And we need to get another model because on average, the waiting should be 15 minutes. Okay. The problem is when we try to compute the expected value of this one, it's going to be infinite. And that's what makes this one a bit different and not good for modeling these behaviors.